Our topic is all about dispersion, scattering, interference, and diffraction of light. First is dispersion. It is the separation of white light into its 7 color components when there is a refraction or bending of light. White light is composed of the different color spectrum, and it is the RGB. So what is prism? It is a piece of glass or transparent material, usually triangular in shape. It allows visible light to pass through, and Isaac Newton first investigated dispersion by allowing white light to pass through. Next is the rainbow. Rainbow is nature's spectacular display of dispersion of light. It usually occurs after a rain shower when there is a huge amount of water droplets suspended in the atmosphere. In 1637, René Descartes first gave a detailed explanation of the formation of rainbow by mathematically tracing the path of light in a spherical drop of water. Now let's proceed to scattering. Scattering is the ability of particles to absorb light and scatter it in all directions. Scattering of light components depends on the size of the particles or scatters. Small particles scatter components of short wavelengths has high frequency, while larger particles scatter longer wavelengths has a low frequency. Our atmosphere is composed of tiny particles that scatter the color components of white light and has an abundance in nitrogen and oxygen particles, which can scatter higher frequency. They scatter violet the most, followed by blue, green, and so on. This selective scattering is called the Rayleigh scattering. At sunset, sunlight travels further through the atmosphere. Longer distance would mean that much of the blue light having shorter wavelengths have been scattered, leaving only yellow, orange, and red having longer wavelengths to be scattered, resulting to a red-orange sunrise or sunset. Another example is the clouds. Clouds appears white because the water droplets in the clouds are larger than the wavelength of light, which scatters all the colors of light equally. Mist scattering occurs when the particles are the same size as or larger than the wavelength of light being scattered. Dust, pollen, water vapor, water droplets, and smoke are common mist scattering particles. And now let's proceed to diffraction. Diffraction is the bending of light when it encounters an obstacle or an opening. The bending of light is not very much noticeable, but when you look around the edges of a shadow, you will notice blurred areas or diffraction fringes. The amount of diffraction depends on the wavelength of light and the size of the obstacle. Illustrates in diagrams A, B, and C that the smaller the opening, the greater the diffraction of light, while the longer the wavelength, the greater is the diffraction of light as shown in diagrams D and E. Now, our last topic is all about interference. Interference refers to the combination of waves traveling in the same medium and at the same time. Waves may combine constructively or destructively in accordance with the superposition principle. This principle states that when two or more waves interfere, the resultant wave is the sum of the individual waves. This is the illustration for interference patterns. And now let's proceed to constructive interference. Constructive interference happens when two identical parts of two waves meet, such as a crest of one wave meets the crest of another wave of the same wavelength. The other part of interference is the destructive interference. It happens when two opposite parts of two waves meet, for example, a crest of one waves meet the through of another wave, which will result in the cancellation of the two waves. In summary, diffraction of light can be shown from two sources or openings. As the waves from these two openings meet, they interfere and produce interference patterns. And the bright fringes are the areas where the waves interfere constructively, while the dark fringes are the areas where the waves interfere destructively. That's all for today's lesson. Thank you for watching.